All right, so we've got the different types of reactions in the bag. You guys did great on that. And we're on to stoichiometry, which is back to the mole highway, but with a roundabout. So what we're going to be doing here is using the balanced equation of a reaction and going from moles of one thing to moles of a different thing. So it's kind of fun. It's just another example of the conversion factors and how we're just going to use our units to guide us. So, I guess what we need to understand about the balanced equation is that this is saying that one particle of this, 5 particles of this, 3 of this, 4 of this all react, and then the laws of conservation are observed. So that's something that we've dealt with in previous chapters. What we want to kind of step up and look at now is that we can also use these as moles. This is a ratio thing, so we can just expand from one molecule to 1 mole, and it's still going to maintain the same ratio. So what I'm saying is, when I have a balanced equation, if I have 5 moles of oxygen reacting with 3 moles of carbon dioxide, then I should have this relationship shown in the balanced equation, and I can use that as a conversion factor, because when I have 3 moles of carbon dioxide, then I know I've got 5 moles of oxygen reacting with it. So this first question is the example on page 125. I'll just make a quick note of that. This is page 125 in your books. And they give you this equation, which you're probably going all over right now, just so, oh, I know what that is. That's a combustion reaction. You'd be right. Absolutely. And so we've got C3H8. You get extra points if you know that that's propane. If you get to the organic chapter, you'll find out why it's propane. It's actually a naming system that says that propane means it's got 3 carbons and a chain of hydrogens as well. So that's kind of fun, but it's just sort of foreshadowing for those of you who actually get to the organic chem chapter. What we need to know here is what mass of carbon dioxide is produced by reacting 2 moles of oxygen. So they've given us moles. They're kind of being nice to us already. They could have given us anything, because we know how to convert anything like volume, mass, number of particles into moles. And so moles is where the exchange happens. If I get some information about one substance, I can change it to moles, and then I can link it to moles of another substance, which is the roundabout part of the mole highway, and then move on. So in this equation, or question, we want the mass of CO2. So I'm going to make a note of that. That's what I'm being asked for. And the thing that they're giving us is that there's 2 moles of oxygen. So right away, I don't really care about things that aren't being mentioned here. So I'm just going to go, okay, I know I need oxygen and carbon dioxide. These are the 2 that I'm interested in. The other ones are just kind of there. We're not using them. And I'm going to start with my 2 moles of oxygen, and I'm just going to create a little mole highway that's going to get me where I need to go. Actually, I think I'm going to move this down just a little bit so that I've got a bit more space to write. So I've got 2 moles of oxygen to start out with, and I know that I don't want moles of oxygen, so I'm going to put the moles of oxygen on the bottom. And right away, I know that I have this moles to moles conversion that's sort of embedded in the balanced equation, and I know that I want CO2. So I'm just going to say, well, I can go to moles of CO2 then. That's a fancy 2. And then I look at the equation, and it says 3 CO2s to 5 moles of oxygen. So there is my conversion factor. And now I'm going to move on, because I don't care really about the moles of CO2. I care about the grams of CO2, because it asks me for the mass of CO2. Well, you can look at your previous stuff from Unit 5 and go, oh, what relates moles and grams? Oh, grams per mole. which is up on the periodic table. So I would need to figure out, I've got oxygen is 16 times 2, carbon is 12, so I got 12, I got 32, looks like it's 44 grams per mole. So I used the periodic table, I used the molar masses, and I figured out that CO2 has a molar mass of 44, so 44 grams per 1 mole, same thing that you did in Unit 5. Now, I've got an equation set up. My moles of O2 cancel out, my moles of CO2 cancel out. I started with a simple thing that wasn't a conversion. I moved through my conversions, and I'm left with the units that I'm looking for, which is mass grams of CO2. So I just run these numbers. I go 2 times 3 times 44 divided by 5, and I'm going to cheat and just go with the answer that's in the book, which you should get as 52.8 grams of CO2. So this is a nice one because it started you out with moles. They could have started you out with grams of one thing and asked for grams of another thing. It just means you have to do one more conversion. Remember that when we're using stoichiometry, we're using the link that's provided on the balanced equation for the ratio between the moles of each substance to go from information about one molecule to information about another one.